Okay, so we're going to look at question number 8, and it says the boat, 48, sorry, the boat leaves the dock at 2 p.m. and travels due south at a speed of 20 kilometers an hour. Another one is heading due east, and it reaches the same dock at 3 p.m. Okay, so which time were the boats closest together? So we need to set up a system, and then we need to find an equation for distance. Well, the equation for distance on a coordinate plane is pretty straightforward. It's going to be a squared plus b squared equals c squared. So we have a boat heading east towards the dock. We'll call the origin the dock. And we're going to say we've got a boat heading south at 20 kilometers an hour. So this is 20 kmh, and this is 15 kmh. Okay, so we want to basically find the distance between those 2 points. Now, it's probably easy. We need to establish where they are in time. So we need to just start sometime at some point. So I'm going to arbitrarily just say t0 equals 12 o'clock. Okay, so 12 p.m. Okay, so then these equations that establish the position of x and the position of y are pretty easy, and we'll just call this x. Okay, x is a function of time, and at 12 o'clock it will be at negative 45. Okay, so it's going to start at negative 45 because I got to go backwards 3 hours from the origin, and it's going to go in the positive direction at 15 kilometers per hour. Okay, so the x position is going to be established by that. The y position, okay, here we're going to say that at time equals 12, so let's go, we're going backwards in time, so the position would be 40, looks like 40 up here, it's going to be somewhere up here, and then the y is going to start at 40, and we're going down at 20 kilometers an hour. Okay, so there's our y position established there. So to come up with an equation for distance, we're just going to say that, well, it's going to be x squared plus y squared equals d squared. And I'm not going to bother square rooting it because I'm just going to say that d squared, if I minimize d squared, I minimize the distance. So then I need to do this in terms of time. So d squared, let's just go d squared first. D squared is going to be 15t minus 45 squared plus 40 minus 20t squared. Okay, there's my d squared. Then I need to differentiate. I need to do d of d squared over dt. And where that's going to be equal to 0 is where I'm going to find either my max or min. So I'm going to differentiate this. Times 15. I need a apply chain rule here, so 240 minus 20t times negative 20. Okay, simplifying this expression, I get 30t. Oops, no, I'm not going to get 30. 15 times 30 is 4. So times 2 is 410. So sorry, 450. 45 times 2 times 15. That's going to give me 1350, I think. So minus 1350. I'd better double check that. 30 times 45. 3 times 45 is, yeah, okay. And then plus negative 20 times 2 times 40 is going to be negative 1600, I think it is. Yeah. Okay, and that's going to be, let's see here, 40, that's going to be negative 1600, and okay, that's correct. And then I'm going to get, that's going to be for my plus 800 t. Okay, so working this out, I'm going to have, let's see, this is equal to 1250 t minus, and that's going to work out to be 2950, okay, is equal to 0, and then solve for t. I'm going to end up with t is equal to 2950 over 1250. We'll probably simplify to, I don't know what that's going to be. It looks like 59 over 5. T equals 59 over 5. Okay.